The purpose of this lab was to measure and track the motion of an object moving at a constant speed without changing directions. For my observations, I took a video of myself pushing a soccer ball in a straight line. Then using the tracker program, I selected the ball's position frame by frame, which gave me a graph of the observed position versus time for the ball. I measured the total distance moved to be 22 feet, which I converted to 6.706 meters. Then I used this data to construct a computational model. I changed the mass of the ball to be 0.43, the velocity to be 2.2, and the delta t to be 0.033. I had measured the mass of the ball, and I calculated the velocity using the slope of the observed position versus time graph. I made the loop to be while t is less than 3.137 because that was the entire runtime of the video. Then I added the equations to update the velocity of the ball, which is Newton's second law, and the position of the ball. However, I also changed the net force to be 0 because the speed was constant. While running the program, the graph looked similar to the observed position versus time graph, but not exactly the same. I graphed both the observed position versus time data and the predicted position versus time data on one graph using Excel in order to make a better comparison. This showed that the predicted position versus time data was linear, while the observed position versus time data was more curved. A big reason that the observed data was different was that some of the beginning data points were before the ball had moved, so the start of the line was more horizontal. Another reason that the observed data is slightly curved is that constant speed is nearly impossible due to friction. The ball was slowly decelerating due to friction, which is why the observed position is consistently lower than the predicted position. The predicted data is the ideal scenario, which disregards friction and other outside forces. When tracking the soccer ball, I selected the origin as the point where the soccer ball was at rest. In the video, I pushed the soccer ball from left to right, so I made the x-axis positive in that direction. However, if I flip the x-axis in the opposite direction, the velocity of the ball would become negative, and the position of the ball would also become negative. The total displacement would be the same, but the position relative to the origin would be different. Another thing to consider is that the net force of the object acting on the object is 0 because it is neither accelerating nor decelerating. This means that the object has the same velocity throughout the entire model. Because speed is constant, it would be impossible to determine the number of pushes and pulls acting on the object to yield a net force equaling 0. There could be any number of forces acting in both directions that cancel each other out, and there is no way to measure any force because acceleration is also 0 due to constant speed. In conclusion, this lab was designed to model an object moving at a constant speed, but it is difficult to simulate constant speed. This was displayed through the comparison between the two sets of data. The observed position was consistently lower than the predicted position due to outside forces. These forces constantly decelerate any moving object, making constant speed nearly impossible.